Okay, today we're going to look at translations. You should have a study guide to follow along, and we're going to fill this in as we go. Okay, so we've got translations as our title. On this page, the page with the chickens, write your definition of a translation. It's a slide. Basically, it moves an object without changing its size or shape and without turning it or flipping it. Okay, so the chicken, okay, from here to here, it didn't get bigger, didn't get smaller, it didn't turn, it didn't flip, it's just a slide. Think of it in terms of an actual slide when you slid on when you were a kid, okay? You just went from the top of the slide and you went down, okay? Here's some other samples. We got the bees, we got the kites, and we can also obviously do this with shapes. Okay. All right, look at your sheet on this one. This might be a little small to view from here, but it says find the coordinates of each vertex of triangle ABC after each translation. Okay, so here's our original triangle. A is at 5, 3, B is at 8, -3, and C is at 0, 2. We want to move the whole thing, in this case, 5 units up. Well, we could do this a couple ways. All right, you could actually physically count 1, 2, 3, 4, 5, and that could be my C prime. 1, 2, 3, 4, 5, and that'd be my A prime. And 1, 2, 3, 4, oops, 1, 2, 3, 4, 5, and that'd be my B prime. Okay, and then I just connect the points like that, and then name the coordinates. Okay, so then I just count over 1, 2, 3, 4, 5, whoops, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, B prime is at 8, 1, 2. And C prime is at 0, 1, 2, 3, 4, 5, 6, 7. 0, 7. Okay, now there's also another way to do this, and that would be, well, if the whole thing is moving up, notice from 0, 2 to 0, 5, the 0 stayed the same. Same thing in our A, the 5 stayed the same. And in the B, the 8 stayed the same. So if it's moving up or down, your Y value is going to change. Okay, in this case, we moved up. So therefore, whatever our Y value is, it's going to increase by whatever numbers we said. In this case, it was 5. So our 2, we just add 5 to it, we get 7. 3, we add 5 to it, we get 8. And -3, we add 5 to it, and we get 2. Okay, either method will work. All right, but there's your answers. Okay. So same thing on this one. We got 4 units to the left and 3 units up. Okay, so if we tried the subtracting and adding method, well, if I go 4 to the left, that means my original point, it was 5, 3. It's going to decrease by 4 because I'm moving to the left. All right, so that 5, subtract 4 from that, that's going to get me 1. Okay, and then my B was 3, my Y was 3. And it's going to go 3 up from that, so it's going to increase by 3. So 3 plus 3 just gets me my 6. Okay? Go over to B prime. My 8 is going to decrease by 4, because I'm moving to the left 4. My -3 is going to increase by 3, okay, because I'm going up, so that's going to be 0. And my C, again, it's going to go 4 to the left, so my 0 is going to change to -4. And then my Y is 2. It's going to go 3 more than that, so that's going to be at 5. Okay? All right, so you've got a blank slate here. I've got a different triangle for you. Go ahead and fill those in, okay? And let me know when you're done. Call me over, and I'll check your answers for you. All right, now this one's a little bit different. It says, another way to describe a translation is to show the change in the coordinates x, y of any point. For example, a translation of 2 units to the right, okay, so visualize that in your head. It's going 2 to the right, and 1 down, okay, is written like this. So you're saying, well, my original point is going to translate, okay, it's going to go 2 to the right, so that means my x is going to increase by 2, and if it's going 1 down, my y is going to decrease by 1, okay? So let's use this. It says, write the coordinates of P prime after each translation of 5, -2. So if my original point is 5, -2, I'm going to translate it along the line. Okay, it's going to go to the right 4. So my x is going to increase by 4. So 5 plus 4 just gets me my 9. Okay, so P prime is at 9. And my y is going to increase by 2. So -2 plus 2 is 0. All right, down here, my x is going to decrease by 3. So same original point. 5 minus 3 just gets me 2. And if nothing is there, that means do nothing to it. Okay, it's not moving up or down. Okay, it's just going to remain at -2. All right? And over here, this time it's not moving left or right. So we just say x is staying the same. So it's going to remain at the 5. And my negative 2 is going to decrease by 5. So I went from negative 2 down 5 from there to negative 7. Okay, you try those 3. And again, call me over when you're ready. This time you're using the point negative 1, 8. And you're using these 3 rules. Okay, so give me p prime for each of these 3. All right, now this one we're going to write the rule. Okay, so it says describe each translation. That doesn't mean in words, that means write a rule. Okay, describe the translation by showing the change in the coordinates x, y of any point. All right, so we're going to take our x, y, and it's going to translate to, well, if it's going to go 3 to the right, that's my x value. If it's going to go to the right, it's going to increase by 3. So it's x plus 3. It's not moving up or down, so my y is going to stay the same. Okay, 5 units down. All right, if I'm moving down, not left or right, that means my original point is going to translate, but the x is going to stay the same. It's just going to move straight down 5. So my y is going to decrease by 5. All right. If you want to try this one quick, if you want to pause quick and see if you can get the answer, all right, and see if you match mine. 7 units to the left. So my x is going to decrease by 7. So here's my original point. It's going to translate to 7 points to the left. So it's going to decrease by 7. It's going up. That means it's going to increase, okay, in this case by 2. Okay, your turn. I've got 4 here for you. Again, we're going to write the rule, okay, for these particular translations. All right, another definition is translational symmetry. It's a design created by translating a pattern. So basically think of like bricks on a wall. It's a repeated pattern. I think of wrapping paper. All right, so if you're wrapping a present and you got Spider-Man, 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 okay, even if I cut this off, okay, I know Spider-Man's not, it's a translation. Okay, and I've got a couple websites here, and we'll see if we're able to see them or not. Here's one. Okay, so their example here, it says a translation slides an object a fixed distance in a given direction. The original object and its translation have the same shape and size. So it's not getting bigger, not getting smaller, okay? They face in the same direction. So like I mentioned before with the slide, same thing on a water slide. Okay, you're supposed to stay, seated, okay, in that direction. Sometimes it doesn't work. So example, they have when you are sliding down a water slide, you are experiencing a translation. Your body is moving at a given distance, the length of the slide, in a given direction. You do not change your size, shape, or the direction in which you are facing. Okay? Now their example is in wallpaper. Okay? Textile patterns, mosaics, artwork. The famous artist M.C. Escher continually used translations, reflections, rotations in his artwork. Okay, if you remember back in the room, okay, I've got posters on the sideboard there that are, some of those are translations. Okay? Down here, we have translations can be seen in architectural design. The stadium seats in this photograph are the same size and shape and face in the same direction. Musicians utilize translations when they compose musical scores. Certain patterns of musical notes are often repeated within a composition. Think of songs you know where a certain tune repeats itself within the song, perhaps in a different octave. Translations can also be found in nature. This picture shows a microscopic view of the scales of a butterfly. So again, that's a translation. And in mathematics, the translation of an object is called its image. If the original object was labeled with letters, like this one says A, B, C, D, E, okay, such as polygon A, B, C, D, E, the image may be labeled with the same letters followed by a prime symbol, okay? It looks kind of like an accent, okay? So it'd be A prime, B prime, C prime, D prime, E prime. That shows you this is the original, this is the new one, okay, or your image. Okay, so for example, it says think of polygon A, B, C, D sliding 2 inches to the right and 1 inch down. In this new position, it's labeled A prime, B prime, C prime, D prime, E prime. Okay? And a translation moves an object without changing its size or shape and without returning it or flipping it. Okay, so we got that one. All right, and this one, I've got my little car. This one's a quick one. All right, it's just showing you an animated version of a translation. Okay, so we have the car moving across the page. And this one might be a little harder to see because it's kind of dark. All right, but there's a mouse Okay, and he's kind of moving across here, there he is there, and then he's in the door, and then apparently up the building, which is weird. But he's still translating, okay? He's not getting bigger, he's not getting smaller, he's just translating. All right, and then I got one more. All right, this is a picture, this is Escher, and I have this on your paper as well, but you can look at it a little closer in detail, but you can see the horse, okay, if you look at the dark, and then if you look at the white, same picture, but it's turned the other direction, okay? So if we go to the website, all right, so this is Escher. All right, so a way to make a translation, you start with a simple square, you subtract a portion, so you like cut a little piece off, and then you add it onto the other side, okay? Thus the result shape preserves the ability to tile, the blah, blah, blah. Okay, so here I'll show you down below. I know this is hard to see, but you can kind of see what it is. But here he kind of explains it a little bit. It says you begin with a simple square grid. Come on. All right, well, there we go. Okay, employ an addition to subtraction method to preserve the tessellation. Okay. And then you just translate it to form the tessellation. Come on. Well, it's not working. There it goes. Okay. All right, down here, this one's kind of cool. This one's more of a, this is a hexagonal tiling. All right, never mind, that's not working. So, but you can look down at the bottom. You can see the horse one. All right. Maybe I can show you this back in class, or maybe I can send you to the website while we're down in the library. So, but you get the idea of what a tessellation is. Okay?